All right, we're trying something new. So the first part, gave us the function f of x, which equals the absolute value, I believe, of x minus 5. And so therefore, it asks us to sketch the graph, which most of you guys did pretty well. But when you sketch the graph here, and we're labeling our axes, this would be an x, this would be y. Then you count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it would be better if I was probably using something else than this. I'm using the iPad, so this is interesting. I forgot my little thing at home, at work, and so I wanted to, anyhow. So this is going to be 0 at 4, 1, at 6, 1. So then you would get an absolute value here, and you would get an absolute value here. Notice characteristics. Absolute value has a corner? And so we know that this is going to be continuous. However, it's not going to be differentiable at 5, but we have to verify it. So when I was going through your here. So when I was going through your work, a couple of things. Now, when you're checking continuity, yes, the limit as x approaches a of f of x has to equal f of a. That's the definition of continuity. And so in this particular case, we're trying to verify the limit as x approaches a. And in this case, let's just kind of clarify that a is, what do we say? 5, and then this is going to be x minus 5 equals f of 5. I can't squeeze that. And so in order for us to do that, we have to go through a couple of things. One, you want to be able to quickly state that f of x in its piecewise form is going to be a minus x minus 5 if x is less than 5, or x minus 5 if x is greater than or equal to 5. And so step 1, you got to verify, does f of 5, does that exist? And in this particular case of how we defined the equals to, then that would say 5 minus 5 equals 0. So f of 5 equals 0. Therefore, f of 5 exists. Then we will have to show the limit. And because I don't want to, I think this is pausable, but I think I'm just going to quickly erase. And I'm going to actually, let's see if I could just stop this. I guess I don't need to. So now what we would need to do is to verify if the, so now what we have to verify, oh my goodness, I don't know, if the limit as x approaches 5 of f of x, does that exist? And so maybe I just need to just go a little bit smaller. Maybe that might do the trick. And in order to verify to see if it exists, we have to verify, does the limit as x approach 5 from the left, which is going to be, and I'm noticing some notations issues. So we want to have a parenthesis. This would be a minus x. This would be a plus 5. When you do your direct substitution, because it's linear and it's continuous, you notice that you get 0. And then, oh my goodness, I guess, can you move this up? Oh. So now you check as the limit as x is approaching 5 from the what? From the right, and the function would be x minus 5, you get 0. And a lot of you are not specifying. You would have to write this down. So then the next case here, since the limit as x approaches 5 from the left of f of x equals the limit as x approaches 5 from the right of f of x, since this is true, therefore that the limit as x approaches 5 of f of x will equal 0. And if I don't see this proper notation, I'm going to have to penalize you points. And then now we verified that the limit as x approaches 5 of f of x does equal f of 5, which, I don't know, I'm writing too big, equals 0. So therefore, f is continuous at 5.